A pleasant good morning or good afternoon or good evening to you, whatever time of day this video catches you. Today I am your instructor and my name is Marik Neri. So we will study the three-dimensional Cartesian space. Let us recall the two-dimensional coordinate system. This is the plane that we are working on for a long time. And when you have a plane, the point on the plane is determined by an ordered pair AB. So how do we plot the point AB? So first we have two axes, the x-axis, which is horizontal, and the y-axis, which is vertical. And these two axes divide the plane into four quadrants. So to locate the point AB, you just locate the value A on the x-axis, and you draw a vertical line through that point, and then you locate the point B on the y-axis, and you draw a horizontal line through that point, and the intersection of these two lines will be your point with coordinates A, B. Now in the three-dimensional system, this is the system which is more familiar to us because this is the space that we live in. So we are living in a three-dimensional space. And to locate a point in 3D space, we need an ordered triple, A, B, C of real numbers. Let us associate a point in three-dimensional space with an ordered triple. And the correspondence between the set of points in space and the set of all ordered triples is called the three-dimensional rectangular coordinate system, or we call it the Cartesian space, and we denote this by R cubed. Now, to represent points in space, first we start with any arbitrary point, and we call that point the origin. And from the origin, we draw three mutually perpendicular lines. So let's start with the first line. We call it the x-axis. And then we draw the second line perpendicular to the x-axis. We call that the y. And then we draw a third line perpendicular to both x and y axes. And we call that the z-axis. And these three axes form the coordinate axis. Now, the coordinate axis determine three coordinate planes. We take it pairwise. So let's say we take the x-axis and the y-axis. The two will form what is called the xy plane. If we take the y-axis and the z-axis, the two will form the yz plane, and the x-axis and the z-axis form the xz plane. Now, these three coordinate planes, they divide the three-dimensional space into 8 regions. And these 8 regions, we call them, or each region in these 8 regions, we call it an octant. And so we have 8 octants. Now, what we do is, by convention, we take the positive x-axis to be the part of the x-axis towards us. The positive y-axis is the part of the y-axis toward us, and the positive z-axis is the one going up. The rest will be the negative parts of the axis. Now, the region where the points will all have positive coordinates, we call this the first octant. And then we travel in the counterclockwise direction. So the second octant is right behind the YZ plane. The third octant is on the other side, and then the fourth octant is on the left side. And then we go down directly below the first octant is the fifth octant, and we also do it in the counterclockwise direction. we also follow what is called the right hand rule. So if you have your right hands, okay, so the right hand, uh, in this case, it's my left. So the right hand rule is the positive z-axis corresponds to the thumb, and then your fingers, they point in the direction of the x-axis, and then your hands or the part of your arm is your y-axis. Okay, so z-axis, x-axis, and this is y-axis. So you always use the right hand. Don't use the left hand in determining the Cartesian axis or the coordinate axis. Okay, so how do we label or mark the points in space? So firstly, we label the origin with the coordinates 0, 0, 0. If I have a point on the x-axis, then the y and the z values there will be both zeros. So the coordinates of this point are a, 0, 0, where a is a real number. On the y-axis, the coordinates will be 0, b, 0, and on the z-axis, 0, 0, c. On the xy plane, take note that on the xy plane, the value of z there is 0. So the coordinates of the points there are AB, 0. On the xz plane, it is the y who is 0. So the coordinates of points on the xz plane will be A, 0, C. And then on the yz plane, it is the x coordinate who is 0. So points on this plane are of the form 0, B, C. So to locate the point ABC, we use um, straight directions in the rectangular system. Okay, so what do I mean by that? So to locate the point ABC, you can start with the point on the x-axis A00 and draw, and then you follow B units parallel to the y-axis. Okay, and you get the point AB0. And then you follow C units parallel to the z-axis. You go from here, you go to B units parallel to the y, and then C units parallel to z, and you get the point ABC. Now take note that you can also do it, you follow along along z first, C units, and then along x, A units, and then along y, B units, and you end at the same point. So for example, locate the following points in space. So firstly, we travel along the positive x-axis 3 units, and then parallel to the negative y-axis 2 units, and then parallel to the negative z-axis, or we go down 6 units, and we get the point 3 minus 2 minus 6. Another point, Q, so we go on the negative x-axis 4 units, and then parallel to the y-axis 3 units, and then going down 5 units, we get the point Q. And last example, 3, 3, 2, we go 3 units along the x-axis, and then 3 units along the y-axis, and 2 units parallel to the z-axis, and we get this point, 3, 3, 2. Now, whenever you have 2 points, we are always interested in how far the points are from one another. Okay? And that denotes the idea of distance. Now, gaano ba sila magkalayo? Okay? So, distance has a formula in two-dimensional space. And we are all familiar with the formula, the square root of the sum of the squares of the differences of the coordinates. Now, if we are in three-dimensional space, then we just do the natural extension of this distance formula to include the third component z. So we just add the term z1 minus z2 quantity squared. Okay, now take note that we really don't have any order in the difference because we are squaring them anyway. So for example, find the distance between the pair of points. So for the first pair, A and B, we get the differences of the x's, and then of the y's, and then of the z's. So 1 minus 9, then we have 0 minus 1, then we have negative 2 minus 2, and then we square them, and then we add the squares, and then we get the square root, and so the distance is 9. So if you're in three-dimensional space and you have these 2 points, you can use a straight edge, a ruler, and then you can show that the distance is indeed 9 units. For the second pair, we use the same formula, 3 minus 2, negative 5 minus 7, it becomes a plus 7, and the 1 minus 3. And this is equal to the square root of 9, which is 3, and that is the distance between Q and R. Okay, so very easy. We just extend the formula for the distance of R2. You just add the third term corresponding to the Z coordinate. Now, another thing that we consider between 2 points is if I have a line segment connecting the 2 points, what is the point in between? Or what is the midpoint? In two-dimensional space, we have the formula for the midpoint of the line segment joining 2 points, and that is given by the averages of the x's and of the y coordinates. So when we have the three-dimensional space, all we do is just extend again the formula by including the third variable z, or the third coordinate z. And in R3, the midpoint formula is the average of the x's, the average of the y's, and the average of the z's. So for example, what is the midpoint of the line segment connecting the 2 points? So for the first pair, we just get 4 plus 2 over 2, and then negative 5 plus negative 7 over 2. That is the same as negative 5 minus 7. And 1 plus negative 3, or that is 1 minus 3 over 2. Simplifying, we get 6 over 2, which is 3, negative 12 over 2, which is negative 6, and negative 2 over 2, which is negative 1. For the second pair, we use the same formula. So 3 plus negative 5, that's 3 minus 5, negative 2 plus 2, 9 plus negative 7, or 9 minus 7. And this simplifies to negative 1, 0, and 1. Now, what are equations of a plane, of planes in RQ? Now let us first recall the linear equation. In the real number line, in R, R is just represented by a line. AX plus B equals 0 represents what? AX plus B equals 0. If you solve for x, you get x equals negative b over a, provided a is not 0, and that is just a point on the line. In R2, the linear equation is ax plus by plus c equals 0. And this represents a line in R2. You can solve for y in terms of the x. Now, how about in R3? So we naturally extend the equation to have the third component cz, and this equation is in fact the equation of a plane, provided that at least one of the coefficients a, b, and c is non-zero. So whenever you see now a linear equation with three variables, x, y, z, the geometrical representation is not a line, it is a plane. So what are equations of the coordinate planes? So first, let's look at the xy plane. Now, what are points on the xy plane? We said that the point on the xy plane has coordinates x, y, 0. So x and y can take any value in R, but z is always 0, or z equals 0. And that is an equation. And in fact, z equals 0 is the equation of the xy plane. Now, how about the xz plane? Here, the y value is 0. The y coordinate is 0, y equals 0, and so the equation is y equals 0. Can you guess what the equation is for the yz plane? What is the equation for the yz plane? That is correct. The equation is x equals 0. Now, how about a plane which is parallel to a coordinate plane? For example, suppose that we have a plane that passes through a point on the x-axis, a0, 0, a not equal to 0, and this plane is parallel to the yz plane. Then the equation of that plane is simply x equals a, because on that plane, the coordinates will always have x equals a. The y and z will vary. Okay? So, for example, consider the plane with equation x equals 2. So on this plane, the points will always have x coordinate equals 2. The y and z coordinates may vary. How about a plane which passes through the point 0, b0 on the y-axis and parallel to the xz plane? So if it is parallel to the xz plane, so the y will always be equal to b. And that is in fact the equation, y equals b. For example, y equals 1. So all points on that plane colored pink will have coordinates x, 1, z. And that will be parallel to the xz plane. And lastly is the point through the x to the z-axis through the point 0, 0, c. C is not equal to 0. And parallel to the xy plane. So the equation is z equals c. For example, say z equals negative 3. So that is parallel to the xy plane. Okay? So these are some introductory equations for planes. Later, we will look at equations of any plane in three-dimensional space. Now let's go to another topic. So let's define a sphere in three-dimensional space. Recall the equation of a circle. In two-dimensional space, a circle is the set of points equidistant from a fixed point. In three-dimensional space, the set of points equidistant from a fixed point is called a sphere. The fixed point is the center, and the distance of the points from the center is called the radius. Now, suppose that we have a sphere with center at C, coordinates HKL, and with radius R. What will be the equation of the sphere? Now, we will make use of the concept that if I have a point XYZ on the sphere, its distance from the center is always R. So we just make use of the distance formula. So the distance of P from C is given by the square root of the sum of the squares of the differences of the coordinates. Okay, so take note, the H, K, and L there will be the coordinates of the center, while the X, Y, and Z are coordinates of the point on the sphere. And this will equal to R for any x, y, z on the sphere. Now, squaring both sides, we get this equation. This is the center radius equation or center radius form of the equation of the sphere. Now, of course, we want to take r here to be greater than 0. Because if r is equal to 0, what do we get? If r is equal to 0, then we just get a point. And that point is what? It is the center itself. So we don't really get a sphere. Now what we get is a degenerate sphere, which is simply a point. Now if the sphere is centered at the origin, then hk and L will be zeros, and the equation will be x squared plus y squared plus z squared equals r squared. For example, what is the center radius form of the equation of the sphere whose center is 3, 1, negative 5, and whose diameter is 8 units long? Now let us be careful here. We want the center radius form, but we are not given the radius outrightly. What we are given is the diameter. So, but we know that the diameter is double the radius, or half the diameter equals the radius. So this tells us that the center is at 3, 1, negative 5, and the radius is equal to 4, which is half of 8. So the equation of the sphere is x minus 3 squared plus y minus 1 squared plus z minus 5 is the same as z plus 5 quantity squared equals 4 squared, 16. Another example. Find the equation of the sphere having the segment joining the points A and B as a diameter. Now take note that the points A, B here are on opposite ends of the diameter of the sphere. So that would tell us that the midpoint of that line segment joining the 2 points will be the center of the sphere. So what do we need? We need to get the center, and that is easily the midpoint of A and B, and that is given by 0 plus 6 over 2, negative 1 plus 3 over 2, 4 plus negative 8 over 2 equals 3, 1, negative 2. And the radius is half the length of the diameter, or that is half the distance of A and B, which is given by this expression, which is 1/2 the square root of 196, which is 1/2 times 14 equals 7. So the equation of the sphere is x minus 3 quantity squared, y minus 1 quantity squared, plus z plus 2 quantity squared equals 7 squared, 49. Okay? Show that the equation, as on the screen, represents a sphere. Now take note that the equation given is not in the center radius form. Okay? What we can do here is we can we can put on one side all the x's, then on the middle part all the y's, and then on the right part all the z's, and then the constants on the right side. Okay? And then we will complete squares. So we get x squared minus 4x. You divide the 4 by 2. You get 2. You square that. You get 4. You add 4. And then for the y, you divide 2y by 2. You get 2. You get 1. And then you square that. You get 1. For 6z, you divide that by 2. You get 3. You square, you get 9. And then you add these values on the left. You also add this on the right. Take note, we already transposed 11. And then we just factor. So the first factor is x minus 2 squared. And then we get y plus 1 squared and z plus 3 squared. The right side is 25. And that is the equation that we want. Now, what is the center of this sphere? The center is clearly 2, -1, -3, and the radius is the square root of 25, which is 5. Let's have some exercises. So we first locate the following points in the space, and then for number 2, we determine midpoints and the equation of a sphere. And for number 3, we sketch portions of given planes. I prepared a solution for these exercises. So for the first part, let us locate the following points in the space. So what we do is first we mark off 2 units on the positive x-axis, and then we go 4 units parallel to the positive y-axis and 1 unit down the z-axis, and that's the point 2, 4, -1. How about this point? So we go 3 units to the negative x-axis, 5 units to the negative y-axis, and 2 units parallel to the positive z-axis, and we get the point -3, -5, 2. Now, the other 2 points, I leave that to you. These are do-it-yourself plotting. Now, for the next set, we want to know the midpoint of DC, where D is the midpoint of the segment AB. So let us first get the coordinates of D. As the midpoint of AB, we just use the formula. So 1 plus 3 over 2, -5 plus 2 over 2, 2 plus -4 over 2. Simplify that. And then we get the midpoint now of DC. So let's call that midpoint M. And now we use the coordinates of D and the coordinates of C. Simplifying, we get -1, -1/4, and 1. So this answers the first problem. Now for the second problem, what is the equation of the sphere centered at the midpoint of the segment AC containing B? So first we need to know the center. So we need to get the midpoint of the segment AC. And that is simply given by 1 plus -4, -5 plus 1, and 2 plus 3 all over 2. And that is given by these coordinates. This becomes the center. Now we want to know the radius. And the radius is simply half of the length of AC. Sorry, that's incorrect. We just need to get the radius of the sphere which contains the point B. So using the equation of the sphere, we get x plus 3 halves quantity squared plus y plus 2 squared plus z minus 5 halves squared. We don't know the value of r yet. Now, since B is on the sphere, then its coordinates must satisfy the equation, meaning if we substitute the values x equals 3, y equals 2, and z equals -4 into the equation of the sphere, then the equation must be satisfied because the point B is on the sphere. Solving the left side, we get the value of r squared, and that is 314 over 4. Hence, the equation of the sphere is given by this. Okay? And last part of the exercise would be sketch a portion of the following planes. The first one is x equals -4. So this must be parallel to the YZ plane and passing through the point -4, 0, 0. Okay, so this is our sketch here. And then how about y equals -2? This must be parallel to the xz plane, passing through the point 0, -2, 0. And this is our graph. And lastly is z is equal to 3. This is parallel to the xy plane, and it passes through the point 0, 0, 3. And this is our sketch. Okay, so I hope you got this correctly. I hope you understood this part of the lesson. We will now proceed to other graphs. These graphs are graphs called conics. And let us start with the parabola. We have extensions of this in three-dimensional space. So for now, let us go back to conics. Suppose that p is greater than 0. A parabola whose vertex is at hk has an equation in one of the following forms. The forms will depend on the orientation of the parabola. If the parabola is opening upward, then the equation is y minus k equals 4p quantity x minus h squared. If the parabola is opening downward, towards the right side here, then the coefficient 4p is multiplied by negative. Pag in-expand natin to, ito yung sinasabi natin na y equals ax squared plus bx plus c if a is greater than 0, opening up, if a is less than 0, opening down. Now you may tell me, sir, why go through the pains of writing the equation of the parabola in this form? Well, because these forms show us the vertex of the parabola. So we can immediately locate the vertex as k and h, and the coordinates of the vertex will be hk. Now take note that the vertex corresponds to the lowest point or the highest point of the parabola, and if you pass a line through the vertex, the line is either vertical or horizontal. It divides the parabola into two similar branches. Okay. Now we can also have parabolas which open to the right, and in this case it is the y who is squared, and the parabola which opens to the left, we have a negative 4 times p there. Now the next conic is called an ellipse. Suppose that a is greater than b and they are both positive values. An ellipse whose center is at C with coordinates hk has one of the two following equations. So in the first one here, we have x minus h squared all over a squared plus y minus k squared all over b squared equals 1. This is an ellipse with a horizontal major axis. This is an ellipse where the elongation is horizontal. On the other hand, if the bigger value a is in the denominator of the y term, then the ellipse has a vertical major axis and the elongation is vertical. So I repeat, if the bigger value a squared is in the x term, then the ellipse is oriented on the horizontal axis. And if the bigger value is in the y term, then the ellipse is elongated vertically. The last kind of conic is called a hyperbola. Suppose that a and b are both positive values. It doesn't matter who is larger than the other. Now let's say that the center of the hyperbola is at hk. Then the equation could be either one of the following. Here on the left side, we have the x term minus the y term equals 1. So firstly, in a hyperbola, you have a minus. In an ellipse, you have a plus. So if the positive coefficient is with the x term and the negative coefficient is with the y term, then the hyperbola is oriented horizontally and we get a horizontal transverse axis. Now, take note that the hyperbola looks like two parabolas facing opposite directions. On the other hand, if the positive coefficient is with the y term and the negative coefficient is with the x term, then we get a hyperbola with a vertical transverse axis. So let's have some exercises. Let us identify the type of conic and let's give a sketch of the graph. So we have 5 equations here. So I prepared a solution for each one. So let's go to the first one, y equals ax squared, where a is greater than 0. What do you think is the graph of this? Now we can rewrite y equals ax squared as y minus 0 equals a times x minus 0 quantity squared. So the two are just the same. And this gives us the equation of a parabola opening where? A is greater than 0, that's the coefficient. This is a parabola opening up. And for example, if the value of a is equal to 1, then we have the graph on screen. What is the vertex of this parabola? The vertex is at 0, 0, or the origin. Now, a can take any values. So if I take a is equal to 1/2, I get the green graph. If a is equal to 2, we get the red graph. So the equation y equals ax squared is in fact a family of parabolas with the same vertex, 0, 0, all opening up. For the second problem, we have x equals 4 minus y squared. We can put this in the parabola form that we have, or the equation of the parabola that we know. This is the same as x minus 4 equals negative of y minus 0 quantity squared. So this is a parabola opening where? So the y is squared, so it's opening either to the left or to the right. And since it is minus, it is opening to the left. And this is the graph of our parabola. What is the vertex? The vertex is at 4, 0. And then for the third one, we have 4x squared plus 9y squared is 36. Take note that this is not in the standard form presented earlier. But if we divide all the terms by 36, then the right side becomes a 1. And 4 over 36 is 1 over 9. And 9 over 36 is 1 over 4. And we get the equation of an ellipse. Now, this is an ellipse whose center, whose major axis is what? Since the bigger denominator is with the x term, the major axis is horizontal. And the center is at the origin. So x minus 0 squared, y minus 0 squared. And we have here the plot of the ellipse. What are the vertices? When we say vertices, this will be the intersections of the ellipse with its major axis and the minor axis. By the way, the minor axis is the axis perpendicular to the major axis through the center. So in this example, the major axis is the horizontal, it's the x-axis, while the minor axis is the vertical, corresponding to the y-axis. So the vertices are, you just set your y to 0, you get your, on the x-axis, you get x is minus 3 or positive 3. On the y-axis, you set your x to 0, you get y is minus 2 or positive 2. These are the vertices. For our next example, by form, this is what? Is this a parabola, a hyperbola, or an ellipse? This is an ellipse. And this ellipse has a center where? At 2, negative 4. Okay, so this is the graph of the ellipse. It's center at 2, negative 4, right here. Now, since the y term gets the bigger denominator, the major axis is vertical. Okay, so we indicate here the major axis. So perpendicular to it is a horizontal minor axis through the center. What are the vertices? So take note that on the minor axis, the value of y is -4. It passes through the center, -4. And you just add 2 on both, or you just add plus or minus 2 to the center 2. So when we add -2 to the center 2, we get -4. We get 0. And then when we add 2, we get 4. So on the minor axis, the coordinates of the vertices are at 0, -4, and at 4, -4. On the major axis, so we get the square root of 16, that's 4, and we add 4 and -4 to the y coordinate of the center, -4. So here you get -4 -4 and 4 -4. And that gives us 2, -8 and 2, 0. So this will be your vertices. This is 2, -8. Here is 2, 0. So what we add is you just get the square roots of your denominators. So I repeat, on the minor axis, the square root of 4, you get the two square roots will be 4 and -2 and +2. You add it to the center. And for the y, the square root of 16 is, you get 4, and then you have the negative also. You add that also to the center y coordinate. And then we have x squared minus 4y squared equals 4. So for this last example, we divide both sides by 4, and we get x squared over 4 minus y squared equals 1. So this is clearly a hyperbola, and the x term gets the positive coordinate or the positive denominator. So the transverse axis is horizontal, and the center is at the origin also, x minus 0 squared, and we have y minus 0 quantity squared. So these are the solutions. These are the conics that we have. The vertices, by the way, will be the intersection of the hyperbola with its transverse axis. So on the transverse axis, the value of y is 0. So you just solve for x using the equation for the hyperbola. Okay? So this completes our introduction for the three-dimensional system. So I hope that the introduction is sufficient. We will move on to the next lecture. So thank you for your attention.